Sometimes some problems can be solved using graphs very easily. So this type of approach will be useful for competitive examinations. So JEE mains or JEE advanced, anything. The best approach is graphical approach. For example, take this problem, f of x is equal to sine of mod x. So to do this type of problem, you should know the fundamental grip over how to draw the graphs. Okay, so first I am going to discuss this problem. F of x is equal to sine of mod x. Sine of mod x, first our mother function. What is the main function? Y is equal to sine x. That is our mother function, main function. First to draw the graph of y is equal to sine x. Yes. So I am drawing the graph of y is equal to sine x. Yes, this is equal to x axis and it is y axis. This is 0, this is pi by 2, this is pi, this is a 3 pi by 2, this is 2 pi. Okay, now coming to left hand side, this is a minus pi by 2, this is minus pi, minus 3 pi by 2 and it is minus 2 pi. So this is a maximum value is 1 and minimum value is minus 1. Now coming to the graph, sine 0 is 0, sine pi by 2 is 1, sine pi again 0, sine 3 pi by 2 minus 1, sine 2 pi. So this is a minus 1, sine 2 pi is 0, 3 pi by 2, so pi. So this is a graph, everybody knows. So this is a y is equal to sine x graph. This is our mother graph. Okay, now, right. Now what is y is equal to sine of mod x graph? Sine of mod x graph, always remember that y axis is there. No, forget about this left hand side. Y axis is there, whatever may be the graph lies on the right side of y axis, take its image, What is the image of this graph? So this is a graph image is this. What is the image? That means you can remove this graph, this part you can remove. Understand this? You can remove this part. What is the image of this portion? This image of that portion is this. You can remove this graph. Understand? So this is a remove, you can graph. Understand? Now the graph you see here, observe here, there is a sharp edge. At x is equal to 0. At x is equal to 0, there is a sharp edge. Therefore, the graph is, the function y is equal to sine of mod x is not differentiable at x is equal to 0. Why? Because here we are taking the image, immediately it starts from here. So here the left hand side derivative and the right hand side derivative both will differ. And why? Because there is a sharp edge here, there you cannot draw a graph. Already I have given that differentiability is nothing but to check the sharpness of a graph, smoothness of a graph. Understand this? Okay, I hope that you understand this solution using graph. So I am going to explain one more graph. Just by seeing the graph only you can say whether it is a differentiable or not. Okay, now so let us see that problem. Welcome to second problem. Discuss the differentiability of the function log of modulus of mod x. Okay, now so let us see that graph. Using graph only I am going to explain this, how to draw the graph. So this is x axis and it is y axis, x axis, y axis. First, what is the mother function? First to draw this graph. So this is the procedure. First to draw the graph of y is equal to x, y is equal to log x graph. Next to draw the graph of y is equal to log of mod x graph, y is equal to log of mod x graph. Next to draw the graph of y is equal to modulus of log of mod. Of course, in the same graph only, don't think that we are drawing three graphs, we are drawing only one graph, right? Everybody knows that the graph of y is equal to log x graph is, so log 1 is equal to 0, so it will be, so this is a 1 and your graph will be like this. So this is the y is equal to log x graph. Understand this. Next one. Y is equal to log of modulus x. Y is equal to log of modulus x. Just now I told, whatever may be the graph lies to the right side of y axis, just to take the image. So that means what? So this will be minus 1. What is the image of this graph with respect to y axis? So this is equal to, so this is the y is equal to log of mod x graph. Okay, now that is over. Now coming to y is equal to modulus of log of mod x graph means what? Then what is the, how to draw this modulus means whatever, that means here y takes only positive values, y takes only positive values, either 0 or positive values. That means whatever may be the graph lies below the y axis, sorry, below the x axis. That means these are all negative y axis. So you don't, y does not take negative values. That's why whatever may be the graph below the x axis, just take the image of that with respect to x axis. So here see the graph of this. Now what is the image of this graph? So this is the image. What is the image of this graph below the x axis? So this is the image. Okay, now you can remove this. You can remove this. Understand? So this is the graph of y is equal to modulus of mod x graph. Understand? Very nice. So if you are able to draw the graph, so we observe that this graph has sharp edges at x is equal to minus 1 and x is equal to 1. Okay, now that means if you find out the left hand side derivative and right hand side derivative at x is equal to 1, definitely they differ the answer. Here also at minus 1, the left hand side derivative and right hand side derivative both have the different answers. Okay, so therefore this graph is not differentiable at x is equal to 1 and x is equal to minus 1. So therefore the number of points of non-differentiability, are 2. What are they? X is equal to 1, x is equal to minus 1. So remaining all cases, you can draw the tangent. Everywhere you can draw the tangent. Here, everywhere you can draw the tangent, but at x is equal to 1 and x is equal to minus 1. So it is not possible to draw the graph. Why? Because possible to draw the tangents. Why? Because here x is equal to 1, x is equal to minus 1. It have the sharp edges. So this problem is solved within seconds if you know the how to draw the graphs. Okay, now I hope that you understand this solution. Let's go for next problem. Welcome to next problem. Discuss the differentiability of the function f of x is equal to minimum of x comma sin x. That means you have to draw the graph of y is equal to x and y is equal to sin x graph, so that the minimum of the graph x and sin x, there we have to check whether the function is differentiable or not. Okay, so first I will draw the graph of y is equal to sin x. So here see here, this is equal to x axis and it is a y axis. This is origin, this is pi by 2, this is pi. So enough, this is a minus pi by 2, this is minus pi, upper limit, sorry, maximum value and minimum value. Yes, we know that the graph is sin 0 is 0, sin pi by 2 and sin pi. So this is a 0 and this is the graph of this function, y is equal to sin x graph. And one more thing is y is equal to sin x graph is over and y is equal to x. Y is equal to x, we know that it is a straight line passing through the origin and lies entirely in first and third quadrants. Okay, now so this is equal to y is equal to x graph. See here, minimum we have to take. So the function is defined like this. F of x is equal to when x value is greater than or equal to 0. That is when x is greater than or equal to 0, which is a minimum, sin x is minimum. Okay, now when x greater than 0, that side. When x is less than 0 or less than or equal to 0, which is the minimum? X is the minimum. Which is the minimum? Minimum. So, x greater than or equal to 0, this side. So, this is the minimum, and here from x less than or equal to 0, the minimum is x. So, this is the nature of the graph. We have taken, he is asked to take the minimum of the graph. Minimum of the graph. Now, find the derivative of this function f dash of x is equal to sin x derivative cos x. So, when x greater than 0, yes, x derivative 1 when x less than 0. Okay, now. So, clearly, so what is the x, what is the 0 plus, what is the right hand side derivative? So, cos 0 value is 1. What is left hand side derivative? That is f dash of 0 minus, this is equal to 1. So, both, so this is the right hand side derivative, this is the left hand side derivative, RHD is equal to LHD. Therefore, we can say that this function is differentiable at x is equal to 0. So, this means what? Here you will have a this y is equal to x acts as a tangential condition. That means your graph will be like this. So, this will be like this. So, that means from 0 to that side it will be there, from 0 to less than it will be a straight line. So, at x is equal to 0, at x is equal to 0, y is equal to x acts as a tangential conditions. Okay, it acts as a tangent. Therefore, at x is equal to 0, the function is differentiable. Okay, now. So, I hope that you understand this solution. So, let us move to some more problems. Welcome to this problem. If f of x is equal to maximum of x square plus 2ax plus 1 and b has 2 points of non-differentiability, then prove that a square is greater than 1 minus b. That means here y is equal to x square plus 2ax plus 1 and y is equal to b. They has 2 points of non-differentiability, means what? The graph, this is a y is equal to x square plus 2ax plus 1 graph. Here x square coefficient is 1, which is positive, and here it is y is equal to b graph. That means they have 2 points of non-differentiability. That means maximum means what here? In these two graphs, which is the maximum? So, that will be the maximum. In this graph, which is the maximum? So, this will be the maximum, and here what is the maximum? This will be the graph maximum. So, these have 2 points of non-differentiability. Okay, now that means y is equal to x square plus 2ax plus 1 is equal to b. This curve, this curve has 2 points of non-differentiability. Therefore, this equation has two roots which are distinct. Distinct means unequal roots it will have. Okay, now. So, therefore, it is see here x square plus 2ax plus 1 minus b is equal to 0. This quadratic equation will have two roots. Why? Because they have two non-differentiable points. Okay, now this means this quadratic equation has two roots, means what? Your delta value should be greater than 0. Delta means what? B square minus 4ac, that is 2a square minus 4 into greater than 0. Here 4 will get cancelled, a square greater than 1 minus b. Okay, now. So, here we got the a square greater than 1 minus b. So, that we proved very easily. So, the graph and this straight line, this parabola and the straight line, they are intersecting at one point. Okay, now. So, this is the maximum, this and again this is maximum. Yet this means total this curve, both they are intersecting at 2 points, means what? They have two roots. That means they have distinct roots. So, distinct roots means delta greater than 0. That's why, therefore, b square minus 4ac greater than 0. So, we got the solution. Okay, now. So, let us go for some more solution problems. Welcome to a new concept here. There is a question arises. Sir, so far we have seen only one function. F of x is equal to sine inverse of 2x by 1 plus x square, modulus of log of mod x, whatever may be that, we have seen one function. There are certain functions which are sum of two functions. Here x square and sin x, it is a sum of two functions. Here log x to the base c plus tan inverse of x, this is a sum of two functions. Sometimes we will come across functions which are sum of two functions or difference of two functions. Then what happens? See here, differentiability of functions obtained by algebraic operations on two given functions. What are the algebraic operations? We have addition, subtraction, multiplication, division. Okay now. So for coming to addition and subtraction, if both the functions are differentiable, f of x, g of x, both are differentiable, both functions are differentiable, then f of x plus or minus g of x is also differentiable. Always, always. That means what here? See here, x square is differentiable and sin x is also differentiable for every x belongs to R. Therefore, their sum x square plus sin x is also differentiable. Log x to the base c is differentiable and tan inverse of x is also differentiable. Therefore, their sum is also differentiable. 2 power x is differentiable. Therefore, and x plus 1 by x is also is differentiable, and total their sum is also differentiable. Understand this? No doubt. If what the condition means, both functions should be differentiable. Therefore, the product sum or difference also differentiable. But what about the quotients are? For example, x square by sin x is there. One function is there. Okay now? Is this differentiable, sir? X square is differentiable and sin x is differentiable? That is not sure. So, if it is differentiable when x is not equal to 0. It is differentiable, both the total x square and upon sin x is also differentiable, where this is called quotient function, where the denominator should not take the value. That means what? X should not be equal to n pi where n belongs to z, except the integral multiples of pi, the function is differentiable. For integral multiples of pi, that means pi, 2 pi, 3 pi, the function is not differentiable. Okay now? So, if the quotient function is there, first of all, we have to remove those points where the denominator is not defined. Then only we can check whether the function is differentiable or not. Okay now? But the question arises, sir, if one function is differentiable, another one is not differentiable, then we are not sure that total function is differentiable or not. Okay. So, let us check some problems based on this concept. If product is there, what happens? For example, x square into sin x is there, then what happens? If one function is differentiable and another function is not differentiable, total function is differentiable or not? That all problems, with theoretical problems we are going to discuss. Welcome to this problem. Discuss the differentiability of the function f of x is equal to mod x minus sine of mod x. We have to discuss the differentiability of this function at x is equal to 0. Okay now, this problem can be done using theoretically. So, no need of any drawing graph or limit h tends to 0, left hand side limit, right hand side derivative, no need of all those things. See here clearly, there are two functions are here, y is equal to mod x and another function is sine of mod x. They are non-differentiable at x is equal to 0. Both the functions mod x and sine of mod x, both are, already we have discussed both the things. Both are non-differentiable at x is equal to 0. But what is their sum? What is their difference? Is differentiable or not? So, this is non-differentiable, this is also non-differentiable at x is equal to 0. Now, we are going to check their difference. Their difference is differentiable or not differentiable. That means we can able to draw the tangent line at x is equal to 0 now or that we are going to see here. Now, I will define this function like this. So, f of x is equal to like that I have discussed. So, x less than 0 and x greater than or equal to 0. Branch function, we call it as a piecewise function or branch wise function. x less than 0. When x less than 0, mod x is equal to minus x by the definition of modulus of a function. Here mod x is equal to minus x, sine of minus x is equal to minus sine x, minus will come outside, this is a plus sine x. Okay now? When x greater than or equal to 0, when x greater than or equal to 0, mod x is equal to how much? X minus mod x is equal to x, this is equal to sine x. Okay, x less than 0, x greater than 0. I have the same function I defined like this. This is called branch wise. So different branches I have taken. Now I will find out this derivative. F dash of x is equal to minus x derivative is minus 1 plus sin x derivative is cos x when x less than 0. Okay, now x derivative is 1 minus sin x derivative cos x greater than 0. Now at x is equal to 0, I will find out left hand side derivative and right hand side derivative. So what is left hand side derivative? That is f dash of 0 minus. F dash of 0 minus means what? Substitute here cos 0. That is a minus 1 plus 1, you are getting 0. That is the left hand side derivative. What is right hand side derivative? Or HD is equal to f dash of 0 plus right side derivative. How the function is defined as 1 minus cos 1. That is equal to 1 minus cos 0. That is 1 minus 1. That is equal to 0. What do you observe here? Here left hand side derivative is equal to right hand side derivative. At x is equal to 0, the function f of x is differentiable. See here, differentiable. That means it is non-differentiable, but the difference is differentiable. I understand this problem. Okay, right. So is this situation, can we conclude that always one function is non-differentiable, therefore the difference is differentiable? No, we cannot say. We cannot say. Understand? If it is both are differentiable, then only their minus or plus is differentiable. If it is any one of the function is non-differentiable, then we have to do the problem. We have to check whether it is a differentiable or not differentiable. In this case, we are getting differentiable function at x is equal to 0. Let us see one more problem. Now welcome to this problem. Discuss the differentiability of the function f of x is equal to mod x plus sine of mod x at x is equal to 0. Now, if you observe here, this graph, this function at x is equal to 0, this is non-differentiable at x is equal to 0. This function is also non-differentiable separately they are non-differentiable at x is equal to 0. Just we have seen the how they are non-differentiable. At x is equal to 0, it will get a sharp edge. At x is equal to 0, this graph is also will get a sharp edge. Therefore, they are not differentiable at x is equal to 0. But their sum, let us check whether they are differentiable or not. So let us see the definition. F of x is equal to right when x greater than 0 and x is less than or equal to 0. When x greater than 0, mod x is equal to x and sine of mod x is equal to sine x. X greater than 0, mod x is mod x. When x is less than 0, mod sine of modulus of x is equal to minus x. Sine of mod x is equal to how much? Sin x. This is equal to minus sin x. Okay, now so this is the actual function. Both are same. But here x is equal to 0. No, I have defined the domain like x greater than 0 and x less than or equal to 0. Now let us see their derivative f dash of x is equal to x derivative 1 sin x derivative cos x when x greater than 0. So here minus x. So this is equal to minus 1 minus sin x derivative cos x when x less than or equal to 0. Okay, now let us check at x is equal to 0 what happens. Let us check x is equal to 0 what happens. At x is equal to 0. Okay, now what is left hand side derivative? Left hand side derivative is that is equal to f dash of 0 plus. What is f dash of x 0 plus means what here? 1. 1 is 1 only. Cos 0 is 1, that you are getting 2. Okay, so here right hand side derivative is equal to f dash of 0 minus right hand side derivative is called minus 1 cos 0 is 1. So minus 1 that is minus 2. What you will see, left hand side derivative is not equal to right hand side derivative. Therefore, the given function f of x is non-differentiable at x is equal to 0. But in the previously, when it is a minus, we got a differentiable, and when it is a plus, we got non-differentiable. From this, we can say one conclusion that if any one of the function is non-differentiable or both differentiable, non-differentiable, then we cannot get a conclusion that their difference are, and the sum is whether that may be differentiable or may not be differentiable. After doing the problem only we can verify. Okay now. So dear students, I hope that you understand today's class with some more topics on differentiability and some more problems which were given in the previous JEE mains examinations. Tomorrow's class I will stand before you. Until then, all the best.